Hello and welcome to Source Zero Conference. I am Vandan Pathak. Today we are going to talk about iOS application security assessment. I am a senior security application consultant with Optiv for a little over 4 years now. I started my career as a SOC analyst and then I switched to network security engineer where I did some network security penetration testing. Recently, I quoted twice by the Reader's Digest magazine in their articles on scams and security of social media. I frequently write blogs, and currently I'm focusing on mobile, cloud, web application, and API security. So let's understand what happened when you turn on your iPhone, when you press the power button. So there are four stages of booting an iPhone. The first stage is boot ROM. The second stage is low-level bootloader. The third stage is iBoot, and the fourth stage is iKernel. The boot ROM is a chip, a read-only memory chip that contains Apple's certificate. It used to verify low-level bootloader, and it doesn't trust any other certificate than the Apple certificate. It contains key pinnings, so the specific private key works on Apple's read-only memory chip. Then after, once the boot ROM load successfully, it goes to low-level bootloader, where it try to find the iBoot image. Uh, Locating an iBoot image is the second stage of bootloader, where it verifies the Apple's signature. And if the signature fails, the phone goes to the recovery mode. So oftentimes when you try to jailbreak the iPhone, the phone gets stuck into the recovery mode. That's the low-level bootloader. After the successful bootloader verification, it goes to iBoot, where it verifies the kernel, and then it goes to iKernel, where it loads the user environment, and you can access your phone book, your contacts, your any applications installed on the phone. So let's talk about iOS mobile application. What iOS mobile application is? These are the apps that get installed on the iPhone or iPad. You can code these applications in either Objective-C or Swift in Xcode. Certain times, developer also uses React Native to code their iOS applications. Uh, Building an iOS application is really depend on the type of applications and the requirement of applications, right? So once the application built, it gets compiled to ARM and encrypted. It then packaged as an IPA file with all the necessary resources. So resources such as the user interface component, application icon, images, browser component, the host that the applications try to reach to, and all those necessary resources are packaged as an IPA file, and then it is ready to install on the iPhone and as an .app directory. All the applications in the iPhone stores install as .app directory. So whenever you try to surf the .app directory, you are surfing the application directory for any specific iOS application. And each application stores, each application has their own app directory. So what happens when you launch the application into the iOS? So first of all, it validates the signature each time the application is executed. So only the code signed by the Apple can execute, and the trusted signature can run on the iOS application. So many times when there are any malicious application for which the code are not signed by Apple, doesn't run on Apple devices. Sometimes you might have experience when you install the iOS application, you might have experienced that the code signature verification failed, which means the iOS application contains a code that hasn't been signed by the Apple. Hence, the application cannot install on the iPhone. Developer can install the trusted certificate So sometimes developer uses third-party component for which they install the certificate in advance into the application environment, so that when application try to execute those third-party components, those certificates gets validate and applications run successfully. All the applications run in the sandbox as a system user. So unlike Android, Android has every single application with its own user, whereas iPhone has every single application runs as a system user in a sandbox environment. So every single application runs with a same system user in a separate sandbox environment. And these separations are maintained by sandbox kernel extension. There are specific kernel extensions that integrated within the iOS that allows and manage this separation when you execute the iOS application. So let's talk about dynamic analysis of the iOS application. One of the great tool that I have encountered is Mobile Security Framework, which is MobSF. Uh, the installation of the tool is pretty simple. You can grab the Docker image from the internet, and you can run the command that I have posted here, Docker run dash it, and you can start the Docker on your port 8000, and then you can access the mobile security framework on in the browser. So what happened when you use the mobile security framework? So the mobile security framework provide abundant types of dynamic analysis component for the iOS application. For example, it checks for the certificate authority. It checks for the weak ciphers in the certificate. It also checks for how many times the app is communicating to any other server other than what has been mentioned in the code. It also checks for the weak functions integrated into the application. So for instance, I have posted here a simple screenshot of the bugs that I have found during the testing of a vulnerable iOS application, where uh, the application is uses the insecure APIs, insecure random functions, and insecure malloc functions. So it also shows that what the severity of the bug and how you can exploit the bug later on. So the dynamic analysis is a uh, first portion of the assessment where you can identify the overall security posture of the iOS application, and you can also um, determine the security score. It also generates the really nice PDF report for once the scan is complete. It also tells you the weak key and key value pair in the plist file. It also tells how many risky permissions are allowed to the applications and how the application is using those risky permission. For example, let's say the application is using camera or contact book or mobile address book. Dynamic analysis of iOS application, plist analysis. So the plist file, as I mentioned earlier, is properties or list files for iOS application. It contains key value pairs. So every single key has a specific value, and iOS application configurations are also inside the plist file. For example, what can be the minimum iOS version required on a device to install the iOS application, or sometimes the plist file contains the sensitive information such as cookies, username, password, protocol handlers. Many of the times, by analyzing the iOS application or iOS plist file for the specific iOS application, you can create an attack scenario where the insufficient protocol handlers are mentioned in the plist file, and you can successfully able to create a connection on an insecure protocol on a third-party host from the iOS application. So that's really sort of kind of vulnerabilities presence in the iOS application. And as a application security as an application security consultant, those are the things we definitely check for every single iOS application. App stores and iOS locate the resources from this file. So the plist file also points the resources where all the necessary components of the applications are located within the application package. Dynamic analysis of iOS application. This another screenshot where I have scanned the uh, vulnerable iOS application, and it has a number of plist file. So, for instance, info.plist, credentials.plist, assets.plist, and etc. So upon looking at the credentials.plist file, you can see the simple key value pair where the username and password is mentioned for the application. This was the test vulnerable iOS application that was scanned on the mobile security framework, and successfully able to pull out the key value pair for the specific plist file. Let's talk about file system and data storage for iOS application. So what else you can look at on the iPhone when you assess an application? So as we discussed that the plist files are the files that um, generate that has a key value pair for the application resources. Other than that, you can also look at the SQLite database. The SQLite database contains a plethora of sensitive information, starting from username, password, how long the app was used, and what sort of functions of the app was used. Uh, what location? Sometimes the database stores the location coordinates, and all sort of sensitive information. Uh, Many of the times these databases are not encrypted. You can simply use the cat command to print the database content, or you can open it into the SQLite browser and you can explore the application database. But in order to obtain the database, you will need to access the file system for the iPhone. Once you access the local storage of the iPhone, you can grab this database from the device. You can explore the database. And many of the times, the values stored in the database are completely plain text. These values are not even encrypted. So attacker can obtain a lot of sensitive information from the database. Next is keychain. So the keychain is the security control that stores the security mechanism stuff. For example, credentials or temporary values that are stored in the keychain for the iOS application. Keychains are kind of the encrypted container that used to store temporary sensitive information when the user is using the application. For instance, credentials or card details or allocation details and stuff like that. The next is temporary files. So the temporary files sometimes store full HTTP request response path. So these temporary files create every single time when user open the iOS applications, and whenever the application make the request to the server and receives the response from the server, it gets stored in the temporary files. Uh, so many of the times when you get access to the local storage, one of the things to look for are the temporary file, cache DB files, plist file, and database files. These all are the local storage locations within the container where you can identify what sort of sensitive information for any applications is being stored on the local device, and how you can prepare the further attack scenario. This is initial foothold into the application security pen testing, where you can understand how the application is code and how secure the data are stored at rest. So that's file system and data storage. One of the challenging stuff when uh, installing the iOS application on the iPhone, especially jailbreaked iPhone, where you can access the iPhones using the SSH. you first of all we need to identify the correct container ID. How you do that is you simply run the app on your cell phone. Then you can connect the phone with a laptop and SSH into the phone, and then you can run the ps space dash capital A command, and then pipe it to grab the application name. So, for instance, in my example, I have used a calculator app. So I wanted to find the bundle directory for the calculator app, where exactly the calculator app is running from. So I run the calculator app, connect my phone with a laptop, and then run the command from my phone. And I found the container directory. So you can see that the big number after the slash application slash is the container ID. And then after there is a directory called calculator.app. As we mentioned earlier, every single app installed in a specific app directory. The container directory contains not just plist file, but also it contains XIB, which is Xcode Interface Builder, and NIB, which is Next Step Interface Builders for user interface. So for instance, what happened when you click on change password from the iOS application? It shows you that you need to enter the old password, new password, confirm the new password. These are the user experience and user interface file that is being stored into the container directory as XIB and NIB files. These are purely the pure purpose of these files are to provide the easy user interface into the iOS application. Proxying through burp. So one of the way to manually uh, understand the security posture of the iOS application is to understand what sort of HTTP request is going to the server and what sort of response coming back from the server to the application. Oftentimes, the attackers use burp proxy or any other proxy tool for that matter to intercept the HTTP request response going from the application. Burp would be helpful in identifying the injection-based flows in iOS application. So there are certain occasions where you can change the HTTP request header from the application and then send it to the server, and then you receive a response. The request contains sort of a malicious payload that gets executes on the iOS application on your iPhone. So this is pure manual testing of iOS application where you can try to uh, perform certain functions on the iOS application while the proxy is on, and you can also understand the overall security mechanism in place from the coding perspective, from the perspective of the pure uh, HTTP request response transactional perspective, how the application is how the application security posture is. To set up a proxy, it is really easy. You need to just install the burp certificate on your iPhone, and then you need to configure your proxy on a specific port, and you can then start intercepting the request and response. Uh, Common errors when you install the burp certificate and try to proxying through burp or any other proxying tool. One of the common errors that always appears is the TLS SSL negotiation failed. So there can be two reasons for that. Number one is that the ciphers that the application is trying to communicate to the server is mismatch, and the TLS handshake failed. That can be the one reason. And the another reason is that the certificate pinning is enabled on the iOS application so that you cannot intercept the HTTP request response. But attacker can always figure out a way to disable the certificate pinning on the iOS application, and then they can explore the local storage, plist file, SQLite database, keychains, and temporary files. There are certain tools that we are going to look in the following slides to understand how can you bypass the certificate pinning for an iOS application. So here proxying through Burp, there are three simple steps. Number one, you can open your Burp suite and you can set up the listener on port 9000. I'm using at least port 9000. Then you can go to your iPhone in the proxy settings from the network. You can just set it to manual and provide the IP of your laptop and then port 9000. And then you can also install the certificate on the iPhone, and the port trigger certificate will install. Runtime mobile security. Now, so far we have looked at dynamic analysis and intercepting the request response for the iOS application. Those are the way dynamically understand and manually understand the security posture of the application. But now let's deep dive into how can you understand what sort of class methods functions are being executed when you open and use the iOS application, when you perform actions on the iOS application. There is a tool called Runtime Mobile Security. This is a GUI tool powered by Frida. Frida is an amazing utility for performing the iOS assessment. So all you need to do is you need to download the Runtime Mobile Security Assessment, and you can just start it in a browser. Usually, the Runtime Mobile Security Assessment starts on port 5000. There is a simple npm package manager that has the Runtime Mobile Security Assessment. You can install that, and then after you can run it in the browser. The Runtime Mobile Security Assessment also allows you to create a customized Frida script. So as I was discussed earlier, that there are certain situations where you need to build the custom Frida script to bypass certain steps on the application. For example, cert pinning or root detections, right? So you can build those scripts and then you can import those scripts into the Runtime Mobile Security Framework, and then you can run those scripts against your specific application. Also, Runtime Mobile Security provides you the list of directories, main directory, bundle path, cache, document, and library directories for the application. So underneath of this, I have also posted a screenshot where I have hooked the calculator app from my iPhone, and there are 5 different directories that it points to where it stores the cache, document, library, and main directory for the calculator app. So hooking the calculator app with the RMS and identifying the input-output hook methods, allowing intercepting sensitive data exchange between the methods. One of the one of the prominent way to understand what exactly data are being exchanged between the methods and functions when you execute certain tasks within the application. That is the important part when you assess the iOS application, to understand what sort of data are stored in the temporary memory and what sort of data are exchanging between two methods, class, and functions in order to perform the desired task on the iOS application. So what you can do is you can hook your application onto the Runtime Mobile Security, and then you can determine the class methods, the stack. You can prepare the whole stack, and you can also hook methods for the iOS application. Over here, my screenshot demonstrates that I hooked the iOS calculator application, and then I was performing the operation, a simple addition operation. And over here, it prints the memory addresses, at which memory addresses, index addresses, and the class names and the methods that it communicates to each time when I perform any operation in a calculator app. Objection, some more Frida stuff. So another command line tool is to inspect and interact with the container file system on the iOS platform. Objection is more of a tool where it you can hook the iOS application and you can dynamically dump certain sensitive values in from the keychains, from the cookies. You can dump the track methods, and you can also determine what sort of cards, methods, and functions are being used into the application. It allows you to dynamically dump argument as you interact with the application. So let's say you have an application which basically allow you to log in, change password, and identify the user type. So let's say what happened, you want to understand what happened when you log in, what number of classes that gets execute, methods and functions, what data are being exchanged between each method and class when you open the application and log in. Objection is the perfect tool for that. And then you can understand the way iOS application handles the data and how insecure it is to identify these data, and then how easy it is for an attacker sometimes to grab this data and prepare the threat attack scenario for the iOS applications. Many of the times, these are the memory level bugs or stack level bugs where the application ended up storing insensitive values on the stack, and it remains there into the keychain or stack forever. You can also dump the keychain entries for specific application. You can bypass the touch ID restriction. There are certain applications which require you to touch your finger before it proceeds to the authentication. So for those applications, Objection is a tool where you can test if you can bypass the authentication and directly goes to the application's secure area, right? Interact with the SQLite database inline of the application. So this particular tool tells you at what time database is updating the data, what sort of data is being constantly updating in the database when you are interacting with the application, and when the application is hooked on the objection tool, and when you are analyzing the database files. So some of the important commands. Number one, how to install and objection. So I strongly recommend installing the objection in an isolated Python environment. So create and activate a new Python virtual environment. Uh, so the first command, virtual env with a space dash dash Python, is a command where you can create a virtual Python environment. Here I have created a Python 3 virtual environment. Once the virtual environment is successfully created, you need to activate the virtual environment. So source command is the command where I have activate my Python 3 environment. Now, once you created the virtual environment, then after every single time, you just need to activate the same virtual environment in order to use the objection. You don't need to create the virtual environment every single time, right? The reason I'm recommending the isolated Python environment for the objection is because if you are not using the isolated environment, then there will be a lot of dependencies error that sometimes really difficult to solve, rather than having an isolated environment for the objection, which basically runs perfectly fine when you attach the iPhone and you can hook any process you want. So once the virtual environment is activated, you can use simple pip command to install the objection. The following pip command install the objection tool on the virtual environment. And then once the objection is successfully installed, you can use the objection command to hook the application. So in my case, I am using objection dash D, which is debug, dash G, which is gadget, then the app name, and then the explore subcommand to explore the application. So once you hook the iOS application with the objection, you can use iOS keychain dump / JSON, where basically dump the whole keychain for the iOS application. Many of the times you also need to identify what sort of cookies and data stored on the local storage for that specific iOS application. So the another command is iOS cookie get dash dash JSON that dumps the only cookies for that particular iOS applications. Uh, it is a great way to extract the sensitive information from the cookies and keychain. The next is hooking class and methods. So the first one is iOS hooking list classes command that basically lists out every single classes, including the parent class and child class for the application that you have hooked with an iOS. Uh, the next command is iOS hooking watch class class name, and then include parent. That's an optional subcommand. For example, if you want to hook an class, but you don't want to hook the parent class, you just want to hook the specific child class, then you can use this command to understand what exactly happening within that class environment when you perform certain actions on the iOS application. Here is a simple screenshot that basically objection tool. I'm trying to dump a keychain and grabbing the playlist file. So my first command is I'm hooking the contact book, the mobile address book for the on the objection. Once it's booked, you can see that com.apple.mobile address book is there hooked using the iPhone's 15.6.1. The first command I tried is iOS info binary. This command tells you what flags are enabled on the specific application. There are certain flags. For example, is it encrypted? The PIE, ARC, and canary flags, and then there's a stack exec flag that basically tells how many memory protections are there are enabled or not for that specific app. Then after I'm trying another command is iOS playlist cat info.playlist. That basically dump the playlist file for that particular app. Attacking iOS web views. So the web views are in-app browser component to display the web pages. iOS web views support JavaScript execution by default. So as I mentioned that the injection-based attacks are possible, especially when the certificate pinnings are disabled, and if you can modify the request header, enter the malicious payload, it reflects back the result. It reflects back the result to on your iOS application. UI WebView, WK WebView, and SF Safari WebView controller are common type of viewing the web in the iOS application. However, the UI web views are deprecated and shouldn't be used. Still, some of the legacy iOS applications uses UI web view. The UI web view has by default JavaScript execution enabled. The SF Safari web view controller is something that when you integrate it with your app, the app takes you, and whenever you click on the app takes you to the Safari browser, inbuilt Safari browser, and allow you to do some stuff for that particular app, and then returns to the app application container. WK web view is a secure web view, although there are certain flags that developer needs to disable manually in order to make sure that the attacker cannot find any malicious link or any deep link kind of vulnerability, because many of the time there are possibility where the attacker can redirect the user on a malicious web portal instead of the authentic web portal and install the rootkit or malware on the iOS application. However, that's not always the case with the iOS pen testing, because Apple has their own security walls on the top of the iOS application. So it is possible to verify if JavaScript is enabled and if WebView has secure content policy set to true or not. So there are two different things that developers must provide their attention to: JavaScript execution and secure content policy. If the JavaScript execution is enabled, then your web view is going to execute the JavaScript. Now, there are certain scenarios where you need to execute the JavaScript to perform specific tasks. However, you can also control that environment and that component where attacker cannot take advantage of executing any malicious JavaScript other than the allowed JavaScript. The secure content policy is a policy where the component makes sure that the content coming from the web to the application is serving on HTTPS and not just HTTP. So the secure content policy makes sure that the application is displaying only secure content and doesn't end up displaying or throwing insecure content. Using Frida, we can load the WebViewInspector.js. This is a custom Frida inspector file for the iOS application. So what does WebViewInspect.js does? So the WebViewInspect.js identify the WebView configuration of the iOS application, if it has a JavaScript execution and secure content policy is allowed or not. So underneath of that, the command I use is Frida dash capital U. Then after you can use the com.apple.app name, that is your vulnerable app or any of the iOS application. Then dash L to specify the location of your webviewinspect.js file. The webviewinspect.js file is a file where you can inspect the WebView controller of your application. So once you execute that command, you can also see the result as on match what exactly happened. It prints the memory address and it prints if it has a secure content policy set to true or not. We can also inspect the heap of Objective C choose method to find instance of the different type of web views and also search for the properties of the web views for JavaScript enable and have secure content policy enable. So web views are really important when you include that component within an iOS application. All right, so far we discussed about how we perform the dynamic analysis of the application using the mobile security framework. How can we disable the certificate pinning and we can manually capture the HTTP request response pair for the applications. How we can use runtime mobile security to hook methods and classes for each application. How we can use objection to hook processes and dump the keychains, dump the temporary files, and analyzing the local storage for the sensitive information. How we can use Frida to execute a specific custom Frida script to check for the web component of the iOS application. Thank you very much. That's all from my end. I hope you have enjoyed the presentation. Please let me know if you have any question and concerns. Thank you.